Okay, hello guys, so welcome once again to my channel. I believe you've always been staying with us. If you haven't, this may be a little bit difficult because I'm not going to be explanatory as I was in the last two videos, so you advise you to get back and watch them, then you come back and join us in this class, alright? Now, I hope you haven't forgotten the formula uv minus is equals to u times v, this u dv u times v minus integral of v du, like that. So we'll be using this to solve this, alright? Now here we are having a little bit complicated problem. We're having x squared and sine x, where sine x is more like a circular function. If you differentiate it, you have cosine x. Differentiate it again, you have sine x minus, forget about the sign now, whether positive or negative. You're going to have cosine x, cosine x, and sine x, unlike a polynomial function. For example, x squared, if you differentiate this, the power will drop from 2 to 1. Differentiate it again, it will become a constant. Differentiate that constant, it becomes 0, just like that, okay? And differentiate from 0, it becomes 0. In short, it remains 0. If you integrate this x squared, the power will be increasing. X cubed to the 4th power, forget about the sign and the denominator, we're not interested in that. But sine of x, if you integrate sine of x, it's actually going to be cosine. Integrate again, something of sine. Cosine. So this one doesn't actually reduce, it doesn't actually end. Just like a circle, it doesn't have a starting point, nothing, and ending point. It just goes like that. Okay, so when we want to deal with integration by parts, because that's what we want to make use of to solve this, we are not going to integrate x cubed, because if you are integrating x squared, because if you are integrating x squared, you get to x cubed to the 4th power and so on, actually getting nowhere. Alright, you are complicating issues. And if you differentiate this one, you're actually getting nowhere. Just cosine, sine, alternating like that. So what do we need to do? The best thing is to watch out and differentiate what will actually have an end, because it's going to reduce. Then you integrate this other part, alright? Just like you're having x squared and e to the x, the derivative and the integral of this is just the same. So you always watch out for that. In the other part, the last two solutions, we didn't really bother ourselves, alright? So here we're going to have an integral of this with respect to this. So for differentiation purpose, I'm going to make this my u relating to this. So I'm going to say let my u be equal to, let our u be x squared, So to differentiate u, I'm going to have du to become 2x, isn't it? The x. So you have du dx is equals to 2x, so cross multiply, I'm going to have du is 2x, the x at the bottom comes up like this, we have 2x dx. Like that, very nice, alright? And since we've gotten our du, we can go ahead and solve for our v. And you know that dv, from what we've been doing earlier, we have dv to be sine x dx, like that, alright? So to get our v, you have to do with integration. So we integrate both sides. So integrating dv, you just get v, and integrating sine x, well, I'll have you know that this integral of sine x is negative cosine x. So we have negative cosine x. The dx is gone. We don't need it again, right? Okay, like that. So we're just gonna go ahead and plug that right in here. We have the integral of, the question is x squared sine of x dx is equal to, well, x squared v negative cosine x, so you multiply that by negative cosine x, alright, minus the integral of v du. V is negative cosine x times du is just 2x dx times 2x dx. This is times, using dots for that because my x is like the times itself. And now we observe a product. Since it's a constant and this negative 1 is also a constant, we can take that to the front of the integration sign. That's it. We're integrating a constant, you can take it to the front of the integration sign. So we're going to take negative 2 out. So we're going to have negative outside, which was there already, times negative 2. And we have the integral of cosine of x. 2 is gone, so we just have times x, alright? So I can put it as x cosine x to avoid confusion, whether the second x is the angle. So we have cosine of x dx like that. All right. And here, out here, we just have x squared times, we have negative of that cosine x, just like that. So we actually have this from here, the integral of x squared sine x dx. So that's what we have. Okay, now we still have something else to integrate here. So this one is actually a little bit complex. Okay, I'm taking time to explain to you. So we having another thing to integrate here. We can still go ahead and use integration by parts for this, isn't it? It is, right? Where here integrating or differentiating x is great. It will be a wonderful idea when you integrate cosine x. Don't go ahead and integrate x and differentiate cosine x, because you're going to get back to this. We don't want that, right? So better still, you differentiate x is going to get to 1, a constant. Very nice. And you integrate this one. So let's just quickly apply integration by parts. I will say let my u be x. So if my u is x, then du be the same thing as dx, isn't it? It is, right? And let my dv be cosine x dx. And if that is the case, then v is just the integral of cosine x is positive sine x, So we have positive sine x like that. Alright? So we just go ahead and use this related to this formula. Don't forget this first result. Here we are having negative times negative 2. So remember that. Don't forget this first result. Well, let's just make some parts of our body white. Okay, so like that here, I will say, okay, let's just bring this in here. So just watch. We're going to have integral of x squared sine x, which is negative x squared cosine x. Now, negative times negative 2 is just positive 2 plus 2 times the integral of x cosine x dx. So right now we are actually working on this, so I will need some space for that. Now, we've gotten what we need already. So I say since my u is x, then the u will then become this. So let's work on this integral. So we have the integral of this to become uv, that is x sine x, uv minus the integral of v du. So this is your v sine x, and your du is just the x. Very nice. So we have only one function to integrate like that. So since this is gotten from the integral of this alone, so we remember your 2 outside as a constant. So you multiply that by 2 and we add it with x squared cosine of x like that. And this was our original question, x squared sine x dx. Okay, so we'll be dealing with this. So what's the integral of sine x? It is negative cosine x. So we have the negative cosine x. That's inside after integrating, it is still a negative outside here waiting for it. So what are we going to say? Well, we're just going to have times negative outside there, and we have x sine x like that. And we multiply everything by 2, and we add it with negative x squared cosine x. So negative times negative gives us positive. We have x sine x plus cosine of x, and 2 is still out waiting for them, and we have x squared cosine x. The negative of that is equals to this, the original question. So here we can see that we can say negative x squared cosine x plus 2x sine x is 2 plus 2 cosine of x. Well, if you like, we can go ahead and do some groupings, where we're going to have cosine x out like that, and we have 2 minus x squared, okay, cosine x, plus 2x sine x to be the integral of x squared sine x dx. Very nice. Okay, everything is just knowing what you want to differential integrate and using the formula appropriately and simplify accordingly. And you remember to add, very, very important, please, never not to forget. I forget sometimes, but always remember to get back. Well, thanks for watching this video. Please subscribe to this channel.